Hello, my name is Michael Drexler. I'm a fellow researcher at the Charisma Institute of Automated Driving, and we are part of the ROADVIEW project. Today I would like to show you the hardware-in-the-loop system which have been developed inside the project. Basically, the hardware-in-the-loop consists of a virtual environment which we choose the Carla simulator. It's an open source tool that enables us to integrate all the development that we have done until now. So we are taking the noise models, the sensor models, the vehicle dynamic models, and also the digital twins that we have developed in the project in the last 2 years, and we have integrated them in our test system using the Carla simulator. Basically, all this virtual environment runs in our hardware-in-the-loop system, and using different simulators, we are able to send all this data to our control unit that represents the same control unit that will be embedded in a serial vehicle. So here in the monitor, it's possible to see our virtual environment consisting of the outdoor test track from the Charisma Institute of Automated Driving with a pedestrian and an ego vehicle. And here we see our control unit, including 3 different sensors: the LiDAR, the radar in pink, and the camera. For doing the injection or for sending the data from the simulation to the control unit, we have been using 3 different methods. So for the camera, we have been using the camera in loop, or the camulator, that is a direct data injection method in which we directly access the hardware of our sensor. Basically, we access the data from a HDMI or DisplayPort cable, and then this equipment converts it to a raw data that is exactly the same as a raw data provided by a real camera, and then this data is injected in our control unit. For the radar, another way, we use an over-the-air methodology in which we manipulate the electromagnetic waves using antennas. So on top we have an anechoic chamber. In this anechoic chamber, on one side we have our radar, and on the other side we have the antennas that are connected to the simulation. They are able to read the data from the radar and from the simulation, and then using this information they manipulate the radar. In this case, the whole simulated data comes from our hardware-in-the-loop system to the VRTS, to the radar stimulator that is connected to the antennas, and on the other side we read the data from the radar that comes back to our control unit. From the LiDAR, another way, we have been using automotive standards, the open simulation interface, to directly send the data from the simulation to the ECU, to the control unit. And this we have been not doing only for good weather conditions, but also for snow, for rain, and for fog. So thank you very much. See you in the next video.